In this lesson, we are going to revise some questions from Science Paper 1 of 2020. Now we'll just focus on section B, and this one was for GCE, the external. Now the first question is: an object of mass 75 kg on Earth is taken to the moon where the gravitational field strength is 1.6 newtons per kg. So we are assuming that we have an object of mass 75 kg on Earth. Now, assuming that this same object is taken to the moon where the gravity is 1.6 newtons, so what mass will this object possess? So the answer for part A, this object will possess 75 kg. Why? Because mass is constant, so mass does not change regardless of the position. Now for question B, we are told to calculate the weight of the object on the moon. So weight is equal to mass multiplied by gravity. So the mass is 75 kg multiplied by 1.6 newtons per kg. So if we multiply 1.6 times 75 is 120. So we have 120 newtons. So the units for weight are newtons, and you also have to make sure that the mass should be in kg whenever you are calculating the weight. Now let's look at question C. State two differences between mass and weight. So the first one, mass is constant. While weight varies. So weight depends on the gravity where an object is. Now for the second part, mass is a scalar quantity. While weight is a vector quantity. So we know that like the same object with a mass of 75 kg, if we say it has a mass of 75 kg, that is only the magnitude. It's not showing us the direction. We can't say 75 kg east or west. That doesn't make sense. So mass is a scalar. It shows the magnitude only. Now for weight we are going to have the weight which is like 120, giving us the magnitude, but there will be the direction such as it will go toward the gravity. So there is direction in the weight, that's why it qualifies to be a vector quantity. Now let's move on to part 2. A bullet of mass 50 grams moving with an initial speed of 500 meters per second penetrates the wall and comes to rest in 0.2 seconds. So let's look at first, if you want, we can have the data. Let's look at the data. So acceleration, we don't have the acceleration, is what we are solving for. Okay, let's look at the final velocity. The final velocity will be taken from this information of it came to rest or it stopped. So the final velocity is always 0. Then our initial we have been given is 500 meters per second. Then time is also given 0.02. So we can now go to the first question. Calculate the deceleration of the bullet over the 0.2 seconds. So let's say acceleration is equal to final velocity minus initial divided by t. So final velocity is 0, minus 500 over 0.2. So 0 minus 500 is 500 over 0.2. So if we divide the 500 divided by 0.2, we get 2000, but our 2000 will be negative meters per second. So 2500 meters per second squared. So the negative tells us that we are looking for deceleration, or we are looking at the acceleration of an object that was coming to rest. Now let's move on. Let's go to part B of question 2. So part B is determine the rotating force on the bullet. So here we can see that we have the mass, and we also have the deceleration. So we are going to use the formula from the second law of motion. Force is equal to mass multiplied by the acceleration. Now mass should be in kg, and the question, we have been given mass in grams, so there is a need of converting from from grams into kg. So let's convert. So 1 kg is equal to 1000 grams. So our 50 grams will be here, then x will cross multiply. So here we have 1000 grams x, then here we are going to get 50 grams kg. You divide by 1000 grams over 1000 grams. So if we cancel, x is equal to, so we can cancel this 0. So 100 into 5 is 0.05 kg. So this is our mass. Now maybe to simplify the work, we can say 1 kg is equal to 1000 grams. So what we are going to do is, if you are converting from kg into grams, you multiply by 1000. Then the reverse, you divide by 1000. Okay, so we can now proceed. So our mass is 0.05 times the deceleration is negative 2500. So we have 2 decimal places here, so we can just ignore the 2 zeros. So we just say negative 25 times 5 is 125 newtons. So the negative in front of this number tells us that it is the force that was opposing the movement of this particular bullet. Okay, now let's move on to question 3. Figure B3.1 below shows a pulley system. And then the first question is, state the velocity ratio of the pulley shown in figure B3.1 above. So velocity ratio. So this one can be found by counting the number of ropes. So 1, 2 here. So we have 2 as our velocity ratio. Or if you want, you can just count the ropes, the circles here. Now for part B, if the efficiency of the machine, which is the pulley, is 75%, what is its mechanical advantage? So efficiency is equal to mechanical advantage divided by velocity ratio times 100%. Now here we can see that we have efficiency is given, then in velocity ratio we have calculated, so we can now find the mechanical advantage. So the efficiency is 75%. Mechanical advantage is what we are looking for, over the VR is 2 times 100%. So we can now proceed here. 75% is equal to, so we can now, 2 there is 1, 2 into 100 is 50%. So 50% times MA is 50% MA. Then we can divide by 50% here, also 50%. So if we cancel, so we cancel this, 50 into 75 is 1.5. So this is our mechanical advantage. And whenever you're dealing with a question like this one, the one that coming from a simple machine like this one, make sure the mechanical advantage should be less than 100, as long as you are dealing with an efficiency less than 100. Then question C, if the load is 120 Newton, what is the size of the effort? So mechanical advantage, we have it, and the load is also given. So we can now say mechanical advantage is equal to load over effort. Our mechanical advantage is 1.5, load is 120, then divided by effort. So over 1 we cross multiply. So 1.5 times E is 1.5. E 1 times 120 is 120. We divide by 1.5. Also here 1.5. So if we divide the 1.5 into 120, this will give us 80. So 80 Newtons. So the force that was applied here was 80 Newtons. So this also makes sense because the effort that we are applying into the machine must be less than the force here that we are trying to overcome. So our point is we are trying to overcome 120. So the machine is making the work to be easy. Instead of applying a 120, we are able to apply this less effort. That's why machining makes the work to be easy. Okay, now let's move on to question D. The question D here, we are trying to find the work that is done by the effort if the load is lifted 0.5 meters. So work is equal to force times the distance. So the force is the effort. So the effort is 80 Newtons times 0.5. So whenever you multiply a number times 0.5, you just have to find the half of that number. So half of 80 is 40. So 40 Newton meters, or we can just say joules. So that is how we can find the equation like this one. Okay, now let's move on to question 4. Waves travel at a speed of 30 meters through a medium. If 10 waves pass through a point per second, calculate the frequency. So frequency is just the number of waves produced per second. So we can just say the answer is also given from the equation. If 10 waves pass through a point per second, so this means that 10 waves were produced per second. So the answer is 10. Now if want, we can use the formula where we have frequency is equal to number of waves divided by time. So the number of waves, we have 10 waves divided by 1, which is per second. 1 into 10, so it's 10 hertz. So this is the number of waves that were produced per second. Now for Roman number 2, wavelength of the wave. So let's look at what we have. We have the frequencies. We have the frequency, which is 10. Then we also have the speed. So we are going to use this formula. Speed or velocity is equal to frequency multiplied by wavelength. So we can make wavelength the substitute formula, or we can just substitute and solve for wavelength. So now let's substitute here. The speed is 30. Then our frequency is 10 times the wavelength. So 10 times wavelength is 10 wavelength. So we divide by 10, also here by 10. So we can see that the wavelength is 3, and take note of the units for wavelength are meters. Then for part B, what does loudness of a sound depends on? So loudness depends on amplitude. Amplitude, or we can just say the amount of energy perceived. So this is how we can simplify a question like this one. Now let's move on to question 5. Figure B 5.1 below shows a ray of light moving from one medium to another medium. So medium A and medium B, these are the two media that we have. Now let's look at the first question here. Find the angle of refraction. So the angle of refraction, so let's first label. So this is the normal ray. Then we have the refracted ray. So the angle of refraction, it's the angle between the normal ray and the refracted ray. So here, whenever you are given an angle at this point, the first step that you need to know is this angle is always equal to 90 degrees. Now from that 90 degrees, we have been given the 65. So what we are going to do is, for us to find the angle of refraction, we just subtract the given angle from 90 always. So you subtract the given angle from 90, so which is 65 from 90. So 90 minus 65 is 25. So this is our answer for part 1. Now let's move on to question B. Calculate the refractive index of medium B. So the symbol for refractive index is small letter n. Then it's sin I over sin R, which is equal to sin I. I is the angle of incidence here. This is our angle of incidence, so it's 50 over sin 25. So the angle of refraction is 25. So if we use now this punch, so we have sin 50 divided by sin 25. So I'm getting the value about 1.81. So this is our refractive index. Now question C, which of the two media is denser than the other? So between medium A and medium B, which one is more denser? So which one has the highest density? So the one with the highest density is medium B. And the reason is, as light moved from medium A into medium B, it bent toward the normal. So whenever light bends toward the normal, that means that the medium is more denser than where it is coming from. Okay, so now let's go to question 6 here. So question 6 here, we are dealing with the lessons. So figure B 6.1 shows an object O placed in front of a thin converging lens of a focal point F. So this is 2F. So focal point number 1 is here, focal point number 2. So even if you are not yet drawn the diagram, what you have to know is, if you place an object at 2F, the image will also be produced at 2F on the other side. then the distance of an image will be equal to the distance of an object. The height of an image will also be equal to the height of an image. So those are the characteristics that you need to have in mind as long as you place an object at 2f. Now for us to complete, we need to draw a line touching this object point here, passes through the center. We need to use a rule. Now, so make sure you use a rule. So now you need to, I'm just trying my level best. So that is our first step. Then the second line, we need to draw a line parallel to the principal axis. Then when it touches the lens, you need to now draw that same line, but that should pass through the point. So if we use a rule, we are expecting these two lines to meet here. So this is where our image is expected to be. So you can use a rule, it will work out perfectly. Now, as for me, I'm not using a rule. Now for question B, state the characteristics of the image formed. So number 1, it is upside down. So it is upside down. So it is upside down. Then the other one, the height of an image is equal to the height of an object. Then the distance of an image is equal to the distance of an object. Then it is formed on the other side of the lens. So those are some of the characteristics that we can give. Now for this one, since the distance of an image and the distance of an object are equal, and the heights of the two are equal to each, we can expect this magnification to be 1. So therefore we can now say magnification is equal to, we can say size of an image divided by size of an object. So if we can measure this distance, this height, and this one. So provided you've used the rule, we are expecting the two to have the same heights. So now let's say if this scale here is 2 centimeters and also here 2 centimeters, so we can say the distance of an object is 4 centimeters divided by, even here we have 1, 2, so it's also 4 centimeters. So if we cancel this, we have 1. So whenever the magnification is 1, therefore the distance of an image is equal to the distance of an object, and the height of an image is also equal to the height of an object. Therefore the image will be formed on the same position as the object, but on the other side. So that's what we have to know for that part. Now let's look at question 7. A step-up transformer increases the voltage of an AC supply from 110 volts to 220 volts. The primary coil dissipates a power of 1.1 kilowatts and the transformer has an efficiency of 100%. So now if the number of turns in the primary coil is 400, how many turns are in the secondary coil? So let's use the formula. So number of turns on the primary over number of turns on the secondary is equal to voltage on the primary divided by voltage on the secondary. So number of turns on the primary, we have it, is 400 over number of turns on the secondary is what we are solving for. Now voltage on the primary is 110 over 220. So from there we can cross multiply. So 110 V times NS, this is 110 V, number of turns on the secondary coil. Then 400, I'll just leave it like that, times 220. So I can divide by 110 also here by 110. So number of turns on the secondary is equal to, so I can cancel this 0, this 0. Then 11 into 11 is 1, 11 into 22 is 2, 2 times 400 is 800. So these were the number of turns on the primary coil, and it makes sense. If we can analyze the data, the primary coil has the voltage of 110, then the secondary has 220. So we can see that if we divide 110 into 200, so we can see that what happened was the voltage doubled. So this number 110 times 2, we have this 120. So we can see that even the number of turns on the primary coil is 400. We are expecting this number also to be doubled, which is equal to 800. So the point is the same ratio that happened to the voltage also should be happened to the number of turns. That's a picture under this transformer. Now let's move on to, okay, so now we can move on to part B, how much current flows in the primary coil. So here we have been given the power in the primary coil, so we'll say power is equal to voltage times the current. So if we want, we can make I the substitute formula. We can just go direct and substitute. Now the power that we have been given is 1.1 kilowatts. Now for us to use this formula, the power should be in watts. So this must be converted into watts by multiplying by 1000 because of the kilo. So this times the 1000, we are going to get 1100. So the power is 1100 is equal to, voltage is 110 times the current. So we can divide by 110, also here 110. So current is equal to 10. So we have 10 amps on the primary coil. Now let's find the current on the secondary coil. We are going to use the principle behind the efficiency of a transformer if it is 100%. So if it is 100% efficient, power on the primary must be equal to power on the secondary. So power on the primary, we have it, or we can just say VI times the VP times the IP, which is voltage on the primary multiplied by current on the primary, is equal to voltage on the secondary times current on the secondary. So voltage on the primary is 110 volts times current is 10 amps. Voltage on the secondary is 220 volts times current on the secondary. So we can divide by 220 also here 220 V. So current on the secondary is equal to, so we can cancel 11 here is 1, 11 into 22 is 2. So we have 1 times 10 is 10 divided by 2, 5 amps. So if we can again analyze what happened is the voltage on the primary is 110 and on the secondary is 220. So the voltage doubled, the number of turns also doubled, but look at what happened to the current. Current on the primary coil is 10 amps, while on the secondary is 5 amps. So the current dropped by half. So this is how the calculation is done. So this type of a transformer that we are dealing with is a step-up transformer because the input voltage is less than the output voltage. Now let's move on to question B. Question 8. Figure B 8.1 below shows two pairs of 3.0 ohms resistor connected to a 6.0 volts battery. So let's label. So we'll say this is resistor 1, this is resistor 2. Then the ones here, we'll consider this resistor 3, this resistor 4. Now resistor 1 and 2 are connected in series. So is resistor 3 and 4. So first, for us to find this should be the total resistance in the circuit between M and N. First, we are going to find the total resistance between the two pairs. So let's find between resistor 1 and 2. So since they are connected in series, we'll say total resistance is equal to resistor 1 plus resistor 2. We have 3 ohms plus 3 ohms, giving us 6 ohms. So that is the total here. Then for the other one, total resistance is equal to resistor 3 plus resistor 4. So it's 3 plus 3, giving us also 6 ohms. So if I can try to redraw this, it's like we have a situation like this one, where we have combined the two to form one. So this is what we have done. So we have 6 ohms here, also 6 ohms here. Now the remaining part is we need to combine the two. Now since they are connected in parallel, we are going to use this formula. 1 over RT is equal to 1 over R1 plus 1 over R2. So this one will be R1, this one will be R2. So 1 over RT is equal to 1 over 6 plus 1 over 6. So no need of finding the lowest common denominator, we already have. So it's 6 into 6, 1 times 1, 1 plus 1. So this will give us 2 over 6. Now, upon reaching here, we can flip the fraction where RT goes up, then 1. So this becomes as RT is equal to, then also do the same here. So this becomes 6 over 2. 2 into 6 is 3. So this is the total resistor. So it means now we've combined the 4 resistors to make one, which is 3 ohms. Now for part B, current through the battery. So we can say we have resistance and we also have voltage. So voltage is equal to current multiplied by resistance. Voltage is here, 6 volts. Current is what we are solving for. Resistance, we use the total, this now single value. Divide by 3 and also by 3. So the current in the battery is equal to 3 into 6 is 2 amps. So this is how we can answer a question like this one. Now let's move on to question C. Power developed in the battery. So power is equal to voltage times current. So voltage is 6, then current we calculated is 2. 2 times 6 is 12 watts. The units for power are watts. Now we can go to the last question. What is the nucleon number of the new nucleus? So we are looking at xenon. Now radioactive iodine is used to treat tumors of the thyroid gland. It decays by emitting beta particle and gamma radiation. So the beta emitting process is represented by the following equation. Okay. Now let us write this equation the way it should be. So we have this iodine. with a mass number of 131, then the atomic number of 53. So we are told it emits beta particle and gamma. We will not focus on gamma, since gamma has no impact on an atom in terms of losing or gaining of electrons and the like. So just consider the emitting beta. So what happens if an element emits beta particles? So the mass number does not change, so this will remain the same. So still going to have 131. Then the atomic number increased by 1, so this becomes 54. Then we have Z plus the notation for this particular radiation. Now the nuclear number, we are trying to find the nuclear number of the new nucleus formed, so this one. So the nuclear number is the other name for mass number. So this is the number here that we are solving for. So the answer for the first part is 131. Now for part B, the half-life of iodine 131 is 8 days. The total dose of the iodine given to a patient initially emits 4 times 10 raised to the power 8 rays per second. Now how many gamma rays does the total dose of iodine emit each second after 24 days? So we are trying to find how many the remaining. So the formula is 2 raised to the power n is equal to A with this 0. This represents original dose divided by this A. So this one, we are saying this one is original dose. So original dose, then this one remaining dose. Now for us to find this, we have the original dose. So for us to find A, first we need to find the value for N. So let's now find the value of N. Now N can be found by the formula. So N is equal to T, which is the total number of decays, divided by the half-life. So the total number here T, we have how many? So total we have 24. So where there is capital letter T, we put 24 over what is the half-life. So the half-life is done after 8 days. So 8 into 24 is 3. So this is the value of N. So we can now substitute. So it's 2 raised to the power 3 is equal to the original value, total dose. The initial one is 4 times 10 raised to the power 8 over A. So over 1. Now 2 raised to the power 3 is 2 times 2 times 2, which is equal to 8. So here we have 8. So 8 times A is 8A is equal to 4 times 10 raised to the power 8. We divide by 8 and also here by 8. So A is equal to, so let's punch this. So we have 4 times 10 to the power 8, then divided by 8. So we have this same as 5 times 10 to the power 7. So this was the remaining value. So that's it for this video. Thanks for watching, and don't forget to subscribe and share.